I'm asked to insulate the walls of this space capsule, and so since I'll be covering the surfaces with insulation, I'm going to need to know the surface area. And like we did in the previous video, we only want to include exposed surfaces, so not every side in this figure is going to be exposed. So let's go ahead and figure out what we need to do. First of all, it's not made up of a single shape, it's made up of two separate shapes. So I'm going to divide my shape into two pieces. The upper part of this space capsule is a hemisphere, so let's do some work for a hemisphere up here. And then the lower portion of this space capsule is a cylinder. So I'm going to have two separate problems to be doing. I'll then add those two surface areas together to get my total exposed surface area of this figure. So let's go ahead and start with the hemisphere. You'll recall, hopefully, that to find the surface area of a hemisphere, we're going to pretend there's a full sphere there. So 4 pi r squared gets me a full sphere, but then because it's only half of it, I'll divide that by 2. So let's just go ahead and get an approximate answer. So 4 times 3.14 times the radius squared, and it looks like, they don't give us the radius, so I'll leave that blank. But notice along the bottom of this, they've said from side to side all the way across down here is 80 feet, which means the diameter of that cylinder or the diameter of that hemisphere, they're going to be the same thing, are both going to be 80, meaning the radius of each one of those is going to be 40. So the radius of my hemisphere along the top is 40, and then like we discussed, it's only half of a sphere, so I'm going to divide that answer by 2. Reaching for a calculator, doing all that work, I'm going to get a final surface area for that piece of 10,048 feet squared. Okay, so go ahead and find that answer. Pause the video, try it on your own, make sure you can get the same answer that I got right there. I'm going to box that answer because I'm going to need it in a little bit. So there's the exposed surface area of the hemisphere. Remember that base portion, that circular base, isn't exposed, so I don't need to include that. So the dome part is the 10,048 feet squared. All right, let's move back to the cylinder. Recall, to find the surface area of a cylinder, we need to find some things. We need the area of the base, we need the perimeter of the base, and then I need the height of the cylinder. So the height of the cylinder is easy. That's just 50 feet. From the bottom circle to the top circle of the cylinder is 50 feet. The area of the base. Well, since the base is a circle, I'm going to find the area of a circle. That's pi r squared. So I'll write down my formula. Once again, reach for a calculator. I want you guys to try that calculation yourself and make sure you're doing the problem with me, not just watching me do it. But that base area comes out to be 50.24. No, I'm sorry, 5,024. See, that's why you guys should be doing this up there, to check my work. 5,024. And then the perimeter of the base, since it's a circle, we don't call it perimeter, we call it circumference. And we'll find it by doing 2 times pi times the radius. That gets me a perimeter of 251.2 feet around. Okay? As in our last video with the silver bullet and werewolf problem, if you watched that one, I want to only include the exposed surface of the cylinder. So the outside, the shell part of this is definitely exposed. That's the lateral surface area, like the label if you think of a soup can going all the way around. From your formula sheet, that part is going to be the perimeter times the height. I also want to see if there's any bases exposed. Well, cylinders have 2 bases. We talked about this top base already. It's not exposed, so I don't want to include that. However, this bottom base, that bottom circle, is exposed to the air or space or whatever, since I guess it's a space capsule. So we do want to include that base, but only one of them. So I'm going to do P times H just plus 1b, which isn't really any of our formulas, but this is a special problem. It's not going to necessarily follow our formulas exactly. So let's get a calculator and figure out the surface area of the cylinder part of the space capsule. So 251.2 is my perimeter, times the height of the space capsule, and then I want to include just one base this time, so 5,024. That piece, that surface area, should come out to be 17,584 feet squared. And again, box that answer because you're going to need it. All right, so at this point, we have the information we need to get the total exposed surface area. We've got about 10,000 from the hemisphere. We've got about 17,500 from the cylinder. Adding those two pieces together gets me a total exposed surface area, whatever you want to call it, of 27,632 square feet. The question, though, wasn't just what's the total exposed surface area, it was how much will it cost to insulate this? Well, they've told me that insulation costs $15 per square foot to install. So every square foot will cost us $15. We have 27,000 square feet. So this is going to be an expensive space capsule, and this is just for the insulation. So multiplying our surface area by 15 should get us our cost to insulate this. I came up with $414,480.